Lesson 66, simplifying radicals and square roots of large numbers. Remember to subscribe to my channel so that you can see the playlist of all these Saxon lessons, as well as a number of resources, especially if you're in my Latin class for some of the other things that we're doing. All right, simplifying radicals. Now, a couple of lessons ago, we talked about the fact that any radical can also be expressed as the radicals of the factors of that number. So, for example, the square root of 18, we can rewrite that as the square roots of two factors of 18. Number of ways we can break down 18. The most helpful, though, is going to be 2 and 9. 2 times 9, 18. So we can rewrite the square root of 18 as the square root of 2 times, we can rewrite square root of 8 as square root of 2 times square root of 4. Now at this point, we notice that square root of 2 we can't do anything with. That's an irrational number. We're not going to be able to get it into a more useful format. However, square root of 9 and square root of 4, those we should recognize right away as things we can easily simplify. Square root of 9 being 3. 3 times 3 is 9. So we can rewrite that as 3 times the square root of 2. Similarly, square root of 4, 2 times 2 is 4, so square root of 4 is 2. We can rewrite as 2 times the square root of 2. Once we get to this point, we notice that we've got like terms here. We've got the same radical in both of these, so we're going to be able to add them together. Radical 2, 3 times the square root of 2, plus 2 times the square root of 2. Now we've got 5 of them added together. And so we can simplify this as 5 times the square root of 2. So square root of 18 plus square root of 8, we broke them down, simplified, and then we see that they're like terms, so we can add them. Now be careful, when you see these two radical 2's there, don't think, oh, radical 2 times radical 2, that gives me 2. No, because we're adding here, not multiplying. If we were multiplying these terms together, it would be a different story. But here we're adding them together. So the best that we can do is combine them as like terms. Let's take a look at another example. 8 times the square root of 27 minus 3 times the square root of 75. Now, because each of these square roots is being multiplied by a coefficient, we have to be careful. Let's use some parentheses to help keep things straight. We'll still use the same procedure with each of these, with taking these numbers under the radical sign and breaking them down into factors to simplify. So the first term, the 8 is going to stay there. We're going to use parentheses to help us not get mixed up. And 27, the easiest thing to break it up into is going to be 3 and 9, since 9 is one of these even squares. So it's square root of 3 times square root of 9. Now we know the square root of 9 is 3, so it's 3 times the square root of 3. 8 times 3 times the square root of 3. Why? Because square root of 27 is radical 3 times radical 9. And radical 9 is 3, so 3 times radical 3. Similarly, with the second term, we're going to break down the radical 75. A couple different ways we could do it, but the most helpful is going to be to get a perfect square out of there. And the perfect square we're going to be able to get is 25. 75 is 3 times 25. Square root of 25 is 5. And then again, the square root of 3. Okay, because we broke square root of 75 down into square root of 25 times square root of 3. Square root of 3 we can't simplify, but square root of 25 we simplify down to 5. Now at this point, it's just going to be a matter of following our order of operations to simplify this. So first we multiply. 8 times 3 is going to give us 24 radical 3 minus 3 times 5 is 15 radical 3. We do have like terms here. We've got radical 3 in both of them, so we can subtract here. 24 minus 15 leaves us with 9. Our answer is 9 radical 3. That's it. Don't be tempted because 9 can be divided by 3. We've got a radical 3 here. Don't be tempted to do anything weird there. You can't do anything else. That radical 3 can't be simplified. If we had another radical 3 to multiply it by, then we could do something else. All right, now what about really large numbers? So what if we have things with lots of zeros in them that we want to find the square roots of? The useful thing to remember here is going to be how powers of 10 work. So 10, we can't really take the square root of 10. Break it down to factors, we get square root of 2 times square root of 5. Those are both irrational. It's not going to help us very much. However, When we start squaring 10, we get some useful things. 10 squared is 100. 100 squared is 10,000. 1,000 squared is a million, and 10,000 squared is 100 million. What do we see in common between each of these? Anytime that we take a power of 10, any power of 10, and we square it, we end up with another power of 10 that has an even number of zeros. So notice 100, 10 squared has 2 zeros. 100 squared, 10,000 has 4 zeros. 1,000 squared, a million has 6 zeros. And 10,000 squared, 100 million has 8 zeros. So anytime that we can make one of the factors of our number a power of 10 that has an even number of zeros, we're going to be able to take a square root of that, and it's going to be a smaller power of 10. So this first example here, square root of 70,000. Now, you notice we've actually already got 4 zeros here. So we'll be able to break this down to square root of 7 times square root of 10,000. Now, 10,000 is a good number to take out as one of our factors because it's got 4 zeros. So we're going to have we're going to have a perfect square of it. So square root of 7 we can't simplify any further, but square root of 10,000, notice up here, 10,000 is 100 squared. So we can simplify square root of 10,000 to 100, and then square root of 7 just stays as it is. That one's pretty straightforward because we already had 4 zeros there. What about this next one, though? Square root of 500,000. Now, this one has 5 zeros, so we're going to have to be a little bit more careful about how we break it up. If we break it up into radical 5 and 100,000, radical 5 and radical 100,000, that's not going to be as useful as if we break it down into radical 50 and radical 10,000. Right, 50 times 10,000 still gives us 500,000, but these will be a bit easier to work with. Square root of 10,000, as we saw already, is 100. So now we've got square root of 50 times 100. Okay, that's better, but we can go a little bit further because 50 we can break down, we can simplify the square root of 50 a bit more. And the easy way to do that is going to be rewrite it as the factors of 2 and 25. So square root of 2 times square root of 25. And remember, this is still being multiplied by 100. The 100 doesn't go away. And 25, that's a perfect square. So we've got square root of 2 times square root of 25, or 5, times 100. Put things together. 5 times 100 is 500. And then square root of 2. So with these really large numbers, you always want to be counting the number of zeros there and getting one of your factors to be a power of 10 that has an even number of zeros, because then you're going to be able to take one of these perfect squares of it. The remaining part of it, whether it's just a single number that can't be simplified any further as a radical, or whether it's something like square root of 50, where we can break it down into 5 radical 2, either way, you're going to have that part, and then you'll have your power of 10 that you'll be able to break down into something like square root of 10,000 being 100. All right, see you next time.